Okay, so today we're going to look at mutually exclusive events and what that means, and actually not just mutually exclusive events, but we're going to look at the way that it affects a problem if events are mutually exclusive or not mutually exclusive. So mutually exclusive is a term you learned in the first unit. So mutually exclusive, it's really important that you actually understand what that means because you could be asked on the test. And what it means is if things are mutually exclusive, it means they cannot happen at the same time. So for instance, like a real life situation where we could talk about this is if somebody said, "Oh man, I'm so bad at math." And someone else's response to them was, "No, you're not. You're so smart." They could say to them, those things aren't mutually exclusive, which means that they can be both really smart and bad at math. And that's true. Some people might be really smart people who just feel like they're not good at math. So there's lots of other things, right, that can happen at the same time, and then there's things that cannot happen at the same time. So for instance, we can't have a football game where you both won and lost. That can't happen. You can tie, but you can't both win and lose. When you're pulling a card from a deck, you can't get a diamond and a black card at the same time because it's going to be one or the other. Okay, so these are mutually exclusive events. So here's a situation where a school newspaper published the results of a survey. And we can see down below, here it is. It says 62% of students skip breakfast. It says 24 skip lunch, and 22% eat both breakfast and lunch. So the first question that we're asked here is, A, are skipping breakfast and skipping lunch mutually exclusive? Now, first of all, we could figure out in this problem, are they mutually exclusive? Like, do all the students who skip lunch necessarily have to eat breakfast or vice versa? But we just want to think, like, logically in this situation, are they mutually exclusive? Is it possible to do both? Can you skip both breakfast and lunch? And of course you can skip both of those. So since you can skip both of them, the answer to that is no. Okay, they are not mutually exclusive because it's possible to do both. I know I've done it myself from day to day. It's not a good idea, of course, but from time to time you just end up, just not eating for whatever reason. So now B, determine the probability that a random student selected skips breakfast but not lunch. So we want to make, in this case with these types of problems, what you want is you want to make a Venn diagram. So this is like unit 1. We're going back to unit 1 here. So if we have, okay, we have breakfast and lunch, okay, and we know that 22%, you have to kind of decide here. Do you want to put the percentage of people who don't have lunch, or do you want to put the percentage of people that skip? I think probably the way we should do this is the percentage of people who skip. So the whole B circle should add up to 62, and the whole L circle should add up to 24. Okay, I think that's what we should do. Now then, where would the 22 go? Okay, what I would expect to have happen here is for students to make a mistake and to put the 22 in the middle. But these students aren't students who skip both, it's people who eat both, so they skip neither. So the 22 actually goes outside, which is a little bit tricky. What it means is that the middle part has to add up to 78, okay, because that's what's left over. So remember, the way we get that is 100 minus 22, which gives me that 78. Okay, so 78 has to do that. Now, where do I go from there? Does anyone remember? Hopefully some of you do. The way that you do this is you take those other two numbers, the 62 and the 24, and you put them together. So that's 86. And you think about the difference. So that's 8 more. So that means 8 goes in the middle. Okay, over here, this would be 54 to make that work. And this one would be 16. So remember the way we get those numbers, because we've done this before, that's why I'm not talking about it too much, but it's 62 minus 8, that's 62 minus 8, and this one here is 24 minus 8. Okay, now B, because I know a whole bunch of you do this, is you don't actually answer the question. So it says skips breakfast but not lunch. So that would be the 54. Okay, that's the number that would be the answer to that question. So for B, you would write, you would write 54%. Okay, and then it says, last question, determine the probability that a randomly selected student skips at least one of breakfast or lunch. So that means that they could skip one or both. So it's all of these numbers together, which add up to 78%. So that's the answer there. So that's how you do this type of question. It's fairly simple. It's like the first unit, and most of you did really well on that. So I think it should be fine. And so hopefully it goes well. Okay, at this next question. Reed's mother buys a new washer and dryer set for $2,500 with a 1-year warranty. She can buy a 3-year extended warranty for $450. Reed researches the repair statistics for this washer and dryer set and finds the data in the table below. Should his mother buy the extended warranty? So here we go. This question, first of all, is sort of subjective because it depends what you feel. But you would need to back it up using some statistics here. So we would expect you to do a Venn diagram. I wouldn't ask a question quite like this on a test because there's no real right answer to it. So I would say, like, what's the chance the dryer is going to break down? I might ask this as part of the question, but I would definitely ask more. So the situation we have here is we have our washer and we have our dryer. And they give us these statistics. So they say there's a 22% chance that the washer is going to break, and a 13% chance that the dryer is going to break, and a 3% chance that they're both going to break. Okay, now this is obviously not mutually exclusive, because if it were mutually exclusive, then there would be no time where both of them could break. But obviously they both can. So the 3 here goes in the middle. Okay. Now what goes in this space here, the dryer? Okay, it's not 13, and I'm sure some people would put 13. It's actually 10, right? And we have 22. It's not 22, it's 19. Okay, so the situation here, that means that there is a 30, that adds up to 32, right? 29, 32, yeah. So there's a 68% chance that there will be nothing wrong at all with our dryer. And that might be enough for most people to say, if there's a 68% chance that nothing's going to go wrong, I'm not going to get this thing. But you should try to break it down here a little bit. There's a 3% chance that you're going to have to spend $700, which is significantly more than the warranty was. I mean, not that much more, 250 more, but still, it's more. Now, this is just the average cost, so they could go completely crazy bad and end up costing way more than that, of course. There's a 10% chance that you will have to spend $300, which is still less than that warranty, so that wouldn't be such a big deal. And there's a 19% chance that you'd have to spend $400, which is also still less than the warranty. I would say with all this data that you would be hard-pressed to say that you should get that warranty. There's only a 3% chance it's actually going to pay off. There's a 68% chance that it won't help you at all, that you would just be spending that money on nothing. So personally here, I would say no, she should not. But I would want to see this kind of math here. Okay, and this is general, just by the way, this is just a general kind of off-topic thing, but usually I would say if you're at a store and they're trying to sell you a warranty, the answer should be no. You may or not be aware, I usually like to have this discussion in person in class, but that in a store like the Brick or Future Shop or Best Buy or whatever it is now, I know that they're always closing and reopening, that those people who work in those stores often earn commission on their sales, which means that they earn a part of what they sell. And a lot of time their commission comes mainly from these warranties. So they are selling them hard. Like, they want to sell them to you because if they sell you a $450 warranty, they know they're going to make money off of that. Like, that's why they sell them. They know that only 32% of people are ever going to make any claim on this. And they're going to pay the employee, like, for each $450 warranty they sell, maybe they pay the employee $100. So just think about that, that these people who are selling these things to you are not honest people. They are trying to make some money. Not that that makes them evil, but just that they have a reason for trying to sell it. So in general, like on TVs or printers or washers and dryers and fridges, no is a good answer on the warranty. But you never know, like some people, sometimes it could come in handy. Okay, let's just look at one more of these problems, okay, and then I'll shut up and let you get to work. A car manufacturer keeps a database of all the cars that are available for sale at all the dealerships in Western Canada. For Model A, the database reports that 43% have heated seats, 36% have a sunroof, and 49% have neither. Okay, so perfect. Even before I read the rest of the question, I know I'm going to make a Venn diagram. I'm going to have leather seats, sunroof. Determine the probability of Model A car at a dealership having both. Okay. Easy peasy. So 49% have neither, so I put that out there. So that means my middle part has to add up to 51. Okay, so I have 36 and 43, which makes 79. So that's quite a bit more. Okay, I have 28% extra there. So 28 goes in the middle. Okay, now 36 minus 28, because remember we're doing that math, minus 28 is 8. So 8 goes here. And 49 minus 28 is 21. So 21 goes there. So the likelihood of having both is 28%. Okay? So these questions are really, really similar to Unit 1 a lot of the time. I know maybe I'll go back to that slide so you can look at it for a minute. I know that I said that many of that I'd only do one more, but I'm going to do one more, just to kind of show you how this works when we're talking about cards, because a lot of the questions on this stuff involve cards, so I just want to make sure that everybody kind of knows what they're doing with it. Or, I mean, it could be dice too or something, right? But anyway, so the difference, last one, but so if I ask you, there's two events usually, so it'll say, hey, I'm drawing a card. Drawing a card, and they want the probability that it will be both these events. So if I say it will be a spade and it will be a 9. Okay, so say that is the kind of question we're asked, and we are asked to find the probability. Okay, so if I was trying to find the probability of this, first of all, just think, if I'm drawing a card, how many options are there? There's 52 options in total. And what you put on top is how many are either a spade or a 9. Now, in a deck of cards, there are 13 spades, okay, and 4 9s. Okay, so if I'm now, if I ask you if it's or, actually here, let's just do two different ones. Not if it's or. I'm going to erase that, sorry. First, let's do A or B, though. So let's do A or B, which means I'm talking a probability if it's a 9 or if it's a spade. Now, the problem with this stuff is that of these 4 9s, 1 is a spade. Right? There's a 9 of diamonds, a 9 of hearts, a 9 of clubs, a 9 of spades. So the 9 of spades can't count twice. If I'm doing A or B, okay, I can't count that 9 twice. So if I'm saying A or B, the probability of that would actually be 16 out of 52, which is 4 out of 13, 4 out of 13, I believe. Let me just make sure that my math is right on that. Yeah. So, so that is either or. So that means if I draw the card, like think about it, it's like you're trying to win. So it's like if you get a spade or a 9, you win. Well, 16 of the cards will do that because there's all 13 spades, including the 9, plus the 9 of hearts, the 9 of clubs, and the 9 of diamonds. So that's 16 in total, because it's 13 plus 3 more. You can't count the 9 of spades twice. Now imagine if we did and. So if I did A and B. So that means that the only way you can win now is if you get a card that's both a spade and a 9. Well, in that case, there's only one. right? Because there's only one 9 of spades. So it's 1 out of 52. So this is a situation where they are not mutually exclusive. And just to talk again, mutually exclusive, for instance, like, there's also the word complement that I haven't talked about and I should have talked about. I'm sorry, this is dragging on a bit. Okay, so if I talked about drawing a card and I talked about hearts and clubs. Okay, well, those are mutually exclusive because there are no hearts that are also clubs. However, they are not complements. Because remember, complements in set theory would mean that if I have H and C, and if this is U, like the whole deck, if I have H and C, okay, if they were complements, they would make up the entire deck. Like the complement of H is everything except H. Well, that would include spades and diamonds. So the complement of hearts is not clubs. So they are not complements. Now, if I said red and black, they are mutually exclusive because you can't have a card that's both red and black. And they are also complements because if I add them together, if I get all the black cards and all the red cards, I have all the cards. Okay, so that's what you should be thinking about here. Thank you guys. I'm going to have the sub give you a worksheet that you need to complete. It's hopefully not going to be too hard, I hope. This part's a little bit easier than the last part actually, and we will have time to review and practice over the next few days, so please don't worry if you're feeling confused. I promise we'll spend some more time on it. Okay, thank you.